Hi, everyone. Thank you for attending GCP Next and coming to our session, Learning Best Practices. My name is Amir Hermelin, and I'm a product manager on Google Cloud Platform, and specifically I focus on Stackdriver. With me here is Thomas.
Hi, I'm Thomas Rast. I'm an SRE on one of the SRE teams that runs the Stackdriver backend part.
And we're here to talk today about alerting best practices and what we've learned monitoring and alerting services at scale at Google, and also helping our users monitor their services on Cloud Platform. A lot of the topics we cover are included in this book, SRE, the Site Reliability Engineering Handbook, and we'll also be giving away a couple of these signed at the end of the session. So worth sticking around.
It's signed by the VP of SRE, which is kind of cool.
So a little bit, let's go over the agenda. So we'll start with a little history on how monitoring and alerting has evolved at Google. Go over an overview and some quick definitions, just so we're all on the same page. And then we can dive into the monitoring and alerting philosophy, the why, the what guides us when we do the things we do. Then we'll go into best practices and lessons learned, and this is the more kind of practical part of the session. Towards the end, we'll talk a little bit about suggested processes, and then we'll wrap up with Q&A. So before we start, slides are not self-explanatory, so if you're just wrapping up that tweet about how wonderful this conference is, go ahead and do that. But then I suggest you focus your attention on us, and I really appreciate it.
So basically, to frame this talk, a very brief history of monitoring since about 2005 at Google. We had a binary there called Borgmon. It's in the book, but you can think of it as Prometheus in recent terms. Prometheus is sort of an external recreation of Borgmon. It's a single binary collection evaluation type monitoring system, and every team would run their own, the core binary. And it has service scale, but you had to scale it manually. You had to arrange it in tiers and pass up aggregations towards the global tier. And there was already sort of a movement towards centralization. So you'd have some support infrastructure that initially was per team, but migrated to be run by what then became Production Monitoring SRE in about 2007 or so, that I'm now a part of. And this infrastructure included things like meta-monitoring. So you want to monitor that your Borgmons actually work. Otherwise, monitoring is kind of useless. You'd have long-term history storage, so you could serve queries over multiple years. And you would have the alerting outbound part. And in 2012, Prodmon SRE took on Monarch as the new state-of-the-art. Monarch is a large distributed monitoring system. If you're interested, there's a great talk by one of the Monarch TLs, John Banning, given at Monitorama 2016. You can find it online. It is Google scale in one system. So we actually literally monitor all of Google in one monitoring system. And it is monitoring as a service in that, as a user, you only have to provide a config. This still requires some knowledge, right? I mean, hence we're here giving talks. But it's much better than having to run your own Borgmons. And this gets us to Stackdriver.
So in 2014, we acquired Stackdriver. And I want to emphasize that Stackdriver is a natural evolution to our cloud users. It does not replace what we've been using for years at Google. So instead of that, it runs on top of Monarch and on top of our alert management system. And it uses the years of experience of running services at scale. But Stackdriver is geared solely towards users of the cloud. It was built for monitoring cloud applications with a focus on an easy getting started experience, very user-friendly UI, and mantra, which is still true today, which we strive to, you don't have to be an expert in monitoring you monitor your services well. So we prefer that you focus your time and energy more on innovation and less on administration. So that was true when we acquired Stackdriver, and it's true today. Stackdriver has evolved to be more than just monitoring, so it offers a wide range of other services, and it supports not just GCP, but also AWS. I'll cover that more towards the end of our talk. So now let's go over some definitions, and we're sure that we're all kind of speaking the same language. So these are commonly used terms in monitoring and alerting. Sometimes they're overloaded, especially the alerting part. So when we talk about monitoring, we're talking about measuring performance, correctness, observing, building instrumentation. So that's really extraction of metrics from our application, from our services, into something useful that we can use for dashboarding and for alerting. Logging is another type of information extraction. Logs are a little different than regular metrics in the sense that they're immutable. They have a timestamp, but they can also serve for monitoring. For example, extracting metrics from logs, putting them in dashboards, alerting on them, et cetera, et cetera. Alerting, again, probably the most overloaded term, and it can be a verb and a noun. So alerting is the process of also configuring your alert rules and maintaining them. It's also the process of detecting issues, opening incidents, and informing is sometimes also called alerting. So the act of informing users that are, that something is wrong with the services that you're running. Then we have debugging or figuring out the root cause. That happens usually after alerting. It's getting down to the problem. It's mitigating the problems. And at the end, when all is well again, we sometimes do postmortems kind of to make sure that whatever happened does not happen again or is treated more efficiently.
User impact will be an important term, and we gave it its own slide for 3 definitions, the SLA, I, and O. To measure something like user impact, SREs especially set themselves service level objectives. So as an example, you might have an uptime objective. Using uptime here as sort of a health check, you just issue an HTTP request and see if it comes back, of say 3 nines, right? 99.9% success. And for every SLO, you would track the corresponding indicator, that's your SLI, which in this case is uptime. There's another term, SLA, which is the actual business agreement entered into with customers. The distinction between A and O is kind of irrelevant to this talk, so we'll skip it. One note here is if you were aiming to go for like 5 nines because you heard, I don't know, Google does it or something, be aware with like everything you hear later, you only have 5 minutes per year for your entire page response up to mitigation if you actually have anything happen.
Okay, so before we dive into the monitoring philosophy and best practices, et cetera, it's very important to look at the process around alerting and around monitoring at a higher level. So Thomas mentioned SLOs. We start by actually defining them. You have to realize what you want to monitor before you start monitoring. It sounds trivial, but we find that sometimes people do it the other way. So think about what are your SLOs, what do you want to monitor, what do you want to put on dashboards, what do you want to instrument. You make sure you get those metrics either from the system that you're using via system level metrics or custom metrics. And then when you have all that, you can start actually configuring your alerts. So you know what you're alerting on, everything all is well, and then an alert triggers. So one thing we want to emphasize with this diagram is, this process is iterative. You're never really at a point where you have the perfect configuration and there's nothing more to do. Because things change, realizations change, SLOs change, your service changes. So it's an iterative process. But especially in the beginning, you should be prepared to kind of change your alerting rules and the way you alert. So if an alert triggers, usually an incident is open, we use that term to define like a problem that somebody needs to take care of. So there's a time span, an incident is active, a notification is being sent, so somebody is handling the issue. Now, the first thing to figure out is if this issue is real. If it is real, you need to mitigate it, debug, maybe escalate. But if it's not real, you need to look at the alerting policy that triggered rather than just getting back to work and not waste time the next time it triggers and see what you need to maybe change in the alert policy or maybe delete. When all said and done, the incident is resolved. If it was real and if it was serious enough, maybe a postmortem is needed, and we go back to this cycle of iterating on your alerting policies. So now let's segue. We're done with the definitions, and we want to segue into a little bit about monitoring, what it is, and what drives good monitoring. So why do we monitor, right? Why are you here? Why do you use a monitoring solution? So these are kind of probably the main use cases. We monitor because we want to detect and analyze trends. It could be business metrics. It could be service metrics. We want to see if our latency is trending up or trending down, or some resources are trending to depletion. We want to compare over time. For example, if it's business metrics, we want to know if cart checkouts, how do they compare to the last season or the last month. If it's latency, how does latency compare to, or error ratio compare to last week? We build dashboards, so we use metrics to build dashboards, so we have an at-a-glance introspection into our services, rather than having to go and do a lot of work each time we want to get some answers to basic questions. Of course, we use metrics for alerting, which is the main topic of this discussion. And we also, debugging is not part of monitoring, but it's very strongly tied into it. Sometimes we instrument metrics that will help us debug, that will help us drill down. We'll go into that later. Sometimes we instrument dashboards just for the debug part, just for the firefighting part. So it's important to mention that. So what do you really want to make sure you're monitoring? This is what we call the 4 golden signals. And that's a painting of the 4 horsemen. So if you want to make sure your service doesn't get to Armageddon level, you want to make sure that you're monitoring these things, at least, right? The first 2 are errors, or error ratio, and latency. Why are these important? These are kind of the outbound-facing metrics of your service. This is how your users view your service. So if your latency is bad, or if you have too many errors, that's immediately reflected in the quality of service that you provide. The other 2, traffic, which is self-explanatory, and saturation, which is really the level that your resources are full, or the level that you're utilizing your resources. You can look at these as kind of the view of your service towards the inside. So this is what your service, if it was a person, this is what it would be seeing. It's seeing the traffic, and it's seeing the saturation internally. And these 2 can lead to error, to errors or bad experiences that will eventually reflect on your users.
So you're measuring these 4 signals, but then there's a question of how, right? And we have an important distinction here, which is the difference between black box or probing and white box monitoring. And so black box is if you monitor from the outside, you're treating the system as a black box, hence the name. The advantage here is it's independent in terms of failure modes, at least largely, usually, which makes it more reliable and is better for alerting. One example here, you might have an uptime check. Again, for a stateful system, you may want a stateful probe, right? You may want to, I don't know, you have a file system, you write a new file, put some content in, read it back, see if it comes back, and then delete it again to clean up. And the opposite is monitoring that works in the cooperation of the system, which is great because you get a lot more detail. And you'll need that detail to do the actual debugging. But again, the failure modes may be tied, and so you usually don't want to rely on this for alerting. A good example of one thing you could not possibly get from black box is the bottom example. If you compare the actual memory handed out by your malloc versus the memory given to your process by the operating system, there's no way you can get that without it being exported from your process, right?
So just to put this in context with the monitoring solution that we offer, just a show of hands, how many of you are familiar with Stackdriver? Great, I'd say 83%. That's good. The ones that aren't, you should be. But the way we offer these, for example, on Stackdriver, which most of you should be familiar with, is black box monitoring is our uptime check, so you should be using that to set up uptime checks, to set up alerts on these and use probes from the outside. White box monitoring, so for example, the system level metrics that are provided for your resources, for example, custom metrics that you as users need to instrument, for example, the logs that are available via the Stackdriver suites. All of that is white box monitoring.
We have 2 slides here about sort of a pet peeve of mine, an FAQ with monitoring is, what is the difference between those two graphs? They're traffic monitored at the system. In this case, the difference is sampling rate. So I made artificial graphs to show the example, but the left one has 1 minute sampling rate, and the right one has 1 second sampling rate. Clicky. And if you have very short spikes on the minute, for example, which happens surprisingly often, you will never see them on a typical 1 minute sampled monitoring system. And again, 1 minute is really typical. 1 second has a significant overhead in terms of like how often you need to go talk to your system, how much it takes to store that data. And another one is if you look at distributions, latencies in particular, so horizontal axis here is latency. If you're just looking at the mean and maybe, I don't know, mean plus sigmas, you're already missing a lot. And maybe you heard about percentiles, right? Percentiles are important. But then the distribution that motivated this slide looks something like this. This is from a caching front end for a storage system. And so the behavior you see is the very low latencies, like sub 10 milliseconds is a cache hit. And the bump at something like 600 milliseconds is if it has to go talk to its backend. And this is exceedingly common, and you will fail to see it if you only look at latencies, at percentiles, excuse me. And this now gets us to the philosophy that you've been waiting for. And we have 3 core points. One, you should really be alerting on symptoms using SLOs. We will have something that you'll see in a slide in a moment that we call the JUAN criterion. It's really, really good to remember it. And we have a human aspect that we'll discuss.
So the first thing, this is a section, by the way, about philosophy. So we're going to talk about the why. And later we're going to show some best practices on more on the how. But the philosophy around alerting on symptoms. This focuses you as somebody that's monitoring their services on the things that really matter to your users. So by alerting only on symptoms, or the vast majority of your alerts related to symptoms, that makes sure, A, that you're not wasting time on meaningless alerts, that may be alerting on things that you could avoid notifying in the first place. And also it focuses you on really the alerts being tied to the quality of service that your users are seeing. The second part of our philosophy is JUAN metrics. These are metrics that you should put every alerting policy through to make sure that it's valid. Assuming you have a finite budget of time, you don't want to be wasting time on meaningless alerts. So any alert that doesn't pass these tests should be a candidate for removal. The first one is judgment. An alert should require human judgment. Otherwise, why waste the person's time? And also, it can really upset people when they get frequently alerted and they feel like, they don't have to think or do anything. It's just they don't have to use any judgment. And that causes churn. It should be urgent, either right now or next business day, because again, if something isn't urgent, why are you diverting focus from other more important things to this if it can wait for a week or even a month? It should be actionable. This one should be clear, but I want to explain it. It means that there should be some action that needs to be taken as a result of this alert, other than reading the alert notification. Now, it doesn't mean that you can mitigate the problem. Take, for example, we know cloud providers, they're always failure-free, but let's say your cloud provider has some sort of failure. You should still know about it, even though there's not much you can do, except email me and others and, hey, what's up? But even then, you want to maybe explain to your users what's going on, or through your page or through your Twitter page, react to that, be on high alert to maybe later divert traffic, et cetera, et cetera. So that's an example where something is actionable, but it's not something that you can do with fixing the service. And the last but not least definitely is necessary. If it doesn't affect anything, users, service, business, why alert on that? Maybe there are other more efficient ways.
The human aspect, the most important one, we think, is you have to consider the stress budget. Every alert triggers a stress response. This is good, right? You need this adrenaline boost to deal with the alert, especially if you're getting it at the middle of the night or something. But this has a cost to the human. It's a very biological thing. And you need to make that budget last. And there are two basic ways you can do this. You can keep the frequency of alerting down, just the pure number, or you can make the human more confident and thereby reduce the stress for the individual alert. And we call this providing help because if you support them in especially the very beginning of the response, if they're better trained, they have better documentation, they will experience less stress. And the second aspect of humans is they're good at pattern recognition and somewhat lazy. Again, SREs automate themselves out of their jobs. In alerts especially, this means that specifically for actionable mostly, people will realize that something is not actionable and start ignoring it, at least subconsciously. And so we have the three core points. Again, symptom-based SLO alerts, JUAN, and the human aspect. And we'll now try and develop some actual best practices that follow from this. First, for SLOs, how do you choose an SLO? Right? This is not necessarily an alerting thing, but it's very important because it's the start of alerting. You should really bound it between what your service can support and what your customers can support. Right? So the service gives you an upper bound of how much you can ask. And if you get that wrong, you put the SLO too tight, your on-callers will burn out. That's like the #1 risk is you get too many pages, your people burn out. If you get the lower bound wrong, then your customers will leave. Right? So you have to get it between those. And just as a side note, the 3 nines of uptime as an SRE tenet also means you have 0.1% of downtime you can use to break stuff, take risks, do something.
We want to augment that. Are you all familiar with the fail whale and Twitter early days? And we actually want to bring up this example as a positive example. You can't always be a perfectionist, and you can't always meet SLOs that please your users. And sometimes you have to make decisions and business decisions, such as not meeting your SLOs because you're experiencing huge growth, and the size of the team and the size of the new users you're getting every day is just too much to meet your SLOs. And that's fine as long as you make a conscious decision and say, you know what, a lot of my users are going to be seeing this, or high latency, or not being able to log in, because right now it's all hands on deck focusing on growth. But it has to be, of course, in a controlled manner, and you have to know why you're not meeting your SLOs. So let's look at JUAN's example matrix. So we talked about why, but let's look at take a few examples for each of the kind of 4 tests. So first of all, judgment. Good judgment is when there's an SLO alert, right? You have to determine where the problem is, or there's some rollout, and you have to determine if the release is good, or maybe you have to roll back the release. So you have to make some judgment there. Bad example is when automated actions, such as server restarts, take care of things, and you still get alerted on it, even though the automated action took care of things. Or when something it isn't, but it can be simply fixed with autoscaling. If autoscaling is doing its job, you shouldn't be alerted on it, even if resources are kind of being stressed. Another test is urgent. So definitely SLO and security issues, both are very, very urgent. You should alert on all of them. But if you find yourself saying something like, well, if this doesn't get fixed, doesn't resolve itself in 12 hours, then we'll look at it. That's a candidate to kind of revisit the alert. Maybe, again, you're wasting time there. And it's important. The reason we're emphasizing this is, again, you have a limited budget for your on-caller churn. So you want to spend that budget, not get to alert fatigue. You want to spend it on the right things versus the wrong things that don't pass this test. So another thing is actionable when you need to determine if something needs rollback, when you need to determine if you need to add capacity and it's not automatically added. A bad example, which is actually quite common, is alerting on CPU percentage, even though, again, autoscaling can handle it. So if autoscaling scales when your CPUs are too stressed, you don't need to alert on that. Or another thing is when just issues go away. So you see this, it alerted, it was red, now it's green, nobody looked at it, and we go on. And it costs time, even if nobody handled that alert. people look at it, and it does cost time. And of course, necessary. So if it affects users, impacts service, impacts business metrics. Anything else is not necessary. If it's covered by other alerting rules, for example. So you see these alerts that fire with other alerts together all the time. So great candidates for removal. Next, some best practice examples of how to think about symptoms. So SLOs are a little bit more obvious, right? You have uptime, latency, errors, error ratios. But internal components, you sometimes also have to alert on them, right? If you look at your internal component and think of it as a service that's servicing other internal components, then you can figure out what are the SLOs of that component towards its peers. And what are kind of the black box metrics that you want to look at when you're looking at that component. For example, if you take batch jobs, for example, if they don't complete on time, something is happening in there, but that might affect other services, and eventually that will affect your users. So you do want to alert on that, and that's actually that is alerting on symptoms.
We do concede that if you have your SLO alerts, sometimes there's one more thing you really want to do, and we call these cliffs, because of how they measure when the system fails catastrophically, as in drives itself off of a cliff. And the typical case here is a resource alert, right? If you write your user data to disk, and you run out of disks, or disk quota, or whatever, you're not going to space today. And the advantage of then having a 90% disk usage, say, for example, alert, which is a very typical thing to do, is it gives you early warning. The SLO alerts would only fire once you've actually exceeded your quota and things are actually broken. I want to call out a distinction here. If SLO alerts are overpaging you and it's hurting you, you need to go and revise the SLO. If a cliff alert is not giving you good signal to noise, just delete it. Right? There's nothing else to adjust. Just delete the alert.
So now we want to spend the next few slides talking about the human factor, which is very important in the alerting equation, and really around two main things. One is what's called alerting fatigue, or alerting frequency, and kind of alerting overload, and it's a big problem, especially at services scale. And the other is remembering that at the other end of the alerting policy that you configure today, another person, completely different person, might be paged. So how do we deal with that? So firstly, with the frequency limits, Thomas, what have we learned over the years?
So SRE has a fairly firm guideline of having 2 outages per 12-hour shift on average at most. You will note I said outages. If you have multiple pages firing for the same outage, it shouldn't be many, right? But it's frequently hard to get it down to really one for every outage. So we don't insist on that. It should be a few. But the 2 outages per 12-hour shift are important. If you get significantly more than this, you'll have burnout. This can be at an actual individual level, where someone literally gets burnout. It can be at the team level, where morale sinks, people leave. And you will get I would call it quality decrease, right? People don't consciously ignore alerts, but subconsciously they kind of no longer have the bandwidth. They do shallow investigations. The postmortems don't really root cause anything. You're never really fixing anything, and so you're never digging yourself out of that hole. You might have far fewer, though I have to say in a sort of second law of thermodynamics sense, this never happens, because the number of pages only increases unless you have an active investment to decrease it. But if this were to happen, right, you might have this, consider 2 points. One is handling pages gives you a lot of practice with the system. It's sort of the most hands-on thing you can do. You can compensate this. You can do training, right? That's not a problem, but you need to make an effort. And you may also ask yourself, is the investment in having SRE support warranted if they're not even getting any pages? And I have some examples here. I want to go in some detail into the first one, the alert cried wolf problem. We had a subsystem of Monarch that would, on average, like once or a couple times per week, have a problem. And the problem would go away. Sometimes you would tweak a setting. Sometimes you wouldn't. Eventually it would go away. And that led to sort of this conditioning that I mentioned, right? It's this subconscious, you know this isn't really a thing. And eventually, of course, the inevitable happened, and we had a real problem, and it was unnoticed for a week. Even though if you knew where to look, you could tell that it was a completely catastrophic failure, that system was not making any progress. It was a batch pipeline. And of course, like in proportion to it being stuck in that state for a week, also the magnitude of the problem then increased. And you really want to avoid this. You see this pattern when people say the alert went away by itself and push back on it. The other two, I think, are somewhat self-explanatory. I just wanted to mention I observed all of these firsthand, right? And so all of this does happen. Watch out for it.
So this is how fatigue actually looks like. This is a screenshot from Stackdriver. The red lines and dots at the top are alerting incidents. And this is a time span from 5 a.m. to 8 a.m. Now, how many of you want to be looking at this at 8 a.m.? Raise your hands. Yeah, and you have to go and figure out which of these alerts are real and how many issues you have and what to do with them. That's clearly too many. At 8 a.m., you want to be drinking coffee and reading the politics section of the newspaper, but not looking at this. So that's an example.
One word on the first thing you do after getting a page. You will, especially if it's an SLO-based page, right? It's probably coming from a prober after what we told you. If in a simple case, the prober might have some backends. So for simplicity, I put 2. You'll want to know, is the problem with one of those? Or is it somewhere behind them so that they uniformly get errors? And we call this drill down. And the drill down might look something like these 2 graphs we have on the next slide. And it tells you, right, if in the first case, you probably assume it's on some backend. In the second case, clearly one of the services is responsible. You just need to hover over the line and restart that guy. I mention this because frequently in a real example, you will have a load balancer in between. And you need to think about how you're going to do the signal which backends you picked from, like how you're extracting that from the prober before the pages happen, right? Because otherwise you're blind and you cannot drill down when you actually have an SLO violation.
So the other thing you want to do to help the human is use dashboards and use what we call documentation. In Stackdriver, sometimes it's called, referred to as runbooks. You want to make sure that whoever responds understands what the alert is about, what was violated, what's the SLO, understand the subsystem, what subsystem it relates to, in your service, where to go, how to mitigate. You have to provide that, especially upfront, and the path to escalation. Now, the most common mistakes that are made are around mitigation and escalation, because when somebody responds, especially if you're going to meet a high level of 9s, the tendency is to go and debug and fix. But actually, the first thing you want to make sure is that the problem is mitigated. Maybe it's already mitigated, but it's going to crash very soon, or maybe you have to do something about it, like roll back, etc. That's the first thing you should do. And then escalation, whoever is in charge of this should provide clear escalation paths. And also, it's desirable to add escalation timelines, so people don't spend too much time being stuck before they refer to their colleagues. So that was kind of, those last few slides were about helping the human. Now we go into another thing, which is the notification methods. You want to have redundancy with your notification methods and not rely on a single alerting notification methods, because problems can occur at the sending end, or problems can occur at the receiving end where the on-call is not able to receive that type of notification. So if it's just n+1, on the right side you have Stackdriver screenshot. It's very easy to add additional notification channels. The free tier includes email and cloud console apps. So we recommend you use both of them for all your alerting policies. If you want additional methods, you can use on-call software like and rotation software like PagerDuty. You can use chat applications, a webhook, or SMS to add to that.
I want to call out SMS here as an SRE, not because it's especially reliable, it totally isn't, but it's the most independent from all the others among these. So if you pick 3 methods, I suggest you put SMS there, because it gives you an independence from all of the others dying simultaneously to some issue in the system. And we have an example of this actually happening. I mean, it's really embarrassing if your pager fails, especially if you're on Prodmon SRE and you're supposed to keep the pager running. We had an example where, due to a mail loop, where every outgoing page would loop back through mail and become a new page, and we delivered about 100 pages per second to a single person. Can you click and show the image?
Oh, there he is.
So I have to admit, this is for a different outage, but that one was on a similar scale. The poor guy actually received a large number of pages. What happened was for the internal one, for the internal paging app, we use an App Engine server backend, and we just used up the entire quota of that backend. And so it became non-functional for all of SRE until someone managed to intervene about, I don't know, 2.5 hours in or so.
I must say, he looks happy for someone that received so many.
He got a T-shirt. Engineers are always happy when they get T-shirts.
That's totally worth it. Something that you might be more familiar with, because it was very, very public, is the DNS outage of late 2016. Many, many prominent services went down, and even though our services were still up and running, a lot of third parties were experiencing failures. So we got a lot of support calls because users were relying on one service that might have gone down, or the APIs are not available, or the email gets rate limited. So again, very important to have redundancy with the way your alerts are getting delivered. So here are some additional best practices. Kind of each slide stands on its own. One thing is grouping. So you want to reduce your alerts, especially similar alerts, that kind of policies that do the same thing for a bunch of resources that act in unison. You want to group them together into a single policy. If it's Stackdriver, you can use Stackdriver groups, which is kind of a concept that is inherent in the platform. But think about when problems occur, you don't want to get paged 100 times. You want one alerting policy to fire, and then know that it relates to a group of resources. One thing to note, though, and remember, is that if you're doing this, you have to have efficient drill down mechanisms, because in many cases, when that alert fires, you will have to kind of investigate and see which of the resources or which components of the group are misbehaving. And that 100-page storm that we saw earlier might sound funny, and that person was smiling after he got the T-shirt, but it does happen every year or two, even inside of Google. So, be prepared for that and be, ahead of the curve.
And do you know how to hack 100 pages that arrived simultaneously?
You do a lot of that.
So we have 2 more slides on process, just like some brief notes. If you organize an on-call rotation, our guideline in SRE is that's for a quick response, right? 24/7 coverage, 5-minute response time to working on the problem, being at the laptop. You want 2 times 6 people in different time zones, or 8 people in the same time zone. Again, this is just a burnout problem. They'll be on call too much if you have fewer people, and they'll burn out over time. Similar to how you have N+1 notification methods, you should probably have N+1 people who get notified. I don't know, the primary might be on the New York subway. They don't have any reception there. So we recommend you have a secondary. This could be someone from some other rotation or someone on the team. And then if that still doesn't work, you escalate to the entire team, because you just need a panic mode, I guess. And what's really worked for us is having, if you're doing weekly shift anyways, it makes a lot of sense having a weekly on-call handoff meeting. This should only take, I don't know, half an hour. And postmortem process, you probably know the basic drill, right? One thing to call out here is we generally write postmortems when either the outage was announced widely, even internally, or there was user impact. But this is somewhat circular, because in the other direction, the saying goes, you should really announce widely, internally at least, if you think you're going to write a postmortem. People learn and develop some experience for this. And one thing to remember in the context of alerting is it's somewhat tempting in a postmortem to draw as an action item, add an alert. This should not usually be your only action item, right? It's justified to add an alert if you could have detected the problem sooner by having this alert, but you should still go and fix the root cause. And postmortems that say add an alert and nothing else are how you get into a situation where you have page overload.
So with all these best practices, we didn't say anything about Google Cloud Platform yet, and we didn't include any plug. So the best practice in my mind is that running monitoring yourself is a lot of overhead, and folks like Thomas are hard to come by, and they're not free. The best thing to do is actually let somebody else do your monitoring. Additionally, if you're running your own monitoring, you have to make sure that it's running correctly, which is called meta-monitoring, monitoring your monitoring. Instead, Google Cloud Platform does offer Stackdriver. And as I mentioned, it's more than just monitoring. It's an integrated suite of products that includes monitoring, logging, alerting functionality, trace, debug, and error reporting. And it's very, very tightly integrated. So for example, a log that you ingest goes into the logging, and you can analyze it there. But if that's an error, it can also trigger error reporting. It can also trigger an alert. You can take that log and extract metrics from it, put it in dashboards, alert on these, or do whatever you want. So the nice thing about it is it's all integrated, out of the box, great experience. And there's a free trial. There's also a free tier. If you're not using it to a large extent, you could stay on the free tier. But even premium pricing is very, very competitive. To our discussion today, it's also geared towards helping you utilize your time better and actually implement best practices around alerting. So it does offer uptime checks to help you focus around SLOs, to help you focus around symptoms. It offers multiple notification methods and runbooks and other kind of custom dashboards to help the person that's responding respond efficiently to alert notifications. It offers great drill down components. So really, we take our experience here and we use it when we're implementing these services. So let's see if we remember everything. If you have to remember just one slide, remember the one with the guy in the t-shirt. No, just kidding. Remember this slide. Let's quickly go over it. The 4 golden signals, you should be monitoring them. Latency and traffic, how your service is viewed from the outside. And latency and errors, how your service is viewed from the outside. Traffic and saturation, how your service looks from the outside inside. Every alert policy should be tested to meet these criteria. Judgment, every alert should be urgent, should be actionable, and definitely necessary. You should be alerting mostly, if not entirely, only on symptoms. And these include SLOs, and you can also alert on cliffs that will induce symptoms. Don't forget the human factor, so limit alert fatigue, limit the amount of pages that somebody can get in a shift, build in debuggability, build in the ability to mitigate and help the on-caller mitigate, and provide a clear escalation path for when people get stuck. More than one notification method is the next thing. Use email, use the Cloud Console app, SMS, whatever, but use more than one. And lastly, remember that the process is iterative, right? So you have to respond efficiently, you have to configure your alerts efficiently, you have to mitigate, and also post-mortem. Even when the problem is gone, let's make things efficient the next time around.